The first one is saying, yeah, it says, is validation and testing said the same thing? What is the difference between testing and validation? Okay, you are asking almost similar question. So the two, like I mentioned, if we are quickly, I take us back to make it clear. It's all about this. You see, if you divide your data into three, then you have validation and testing separately. You see, the idea is this. Once you train your system, here, let's see, I don't want to show you, I want another thing also. I think I show you earlier. Yeah, let me show you this. Look at this diagram. Here you have the data, you gather your data, pre-process your data, you build your model. This is training here. This is training. So model testing. When you test your model, maybe I'm getting 92%. I'm not okay with it. I need to go back and do parameter tuning. I change it again. I do it again. You see, this is training and testing. However, after I've done with that, I still have another data. I can use my data, we call it validation, to check again that, okay, what is the final result I'm getting? I've done a lot of parameter optimization, and now is the final stuff. I'm okay. I'm going to check it again. Sometimes this data may come from the client, from the industry. They send data to us, maybe 1,000 data. We use 700 for training and 300 for testing. That's fine. When we finish, we talk to them, we are done. Some of them send out another data to test again, to be sure it is okay. We call it validation. Validation and testing sets, sometimes I use interchangeably, which is okay. However, you cannot repeat testing set in two ways. So if you have validation, the next one is going to be testing. If you call it testing, the next is going to be validation. You see, the two is about checking that what you have trained is actually going to work on unseen data. Because if we remember, when we define machine learning hypothesis, the hypothesis theory, it says if it works on enough data, it will work on unseen samples. Is it going to work on new samples? This is the question you are trying to answer. So that is why when your division is only having two options, then you don't talk of, in that case, testing set can also be considered as validation because you have only one. They are not two. So after the training, somebody will say, I'm going to test it. That's fine. Some people say, okay, after training, I'm going to validate it. It's okay. So either you call it testing, you call it validation, that is okay. What it's doing is, I want to use the set aside data to validate what I've done. To test what I've done. Testing or validation is to check if what you have trained is well trained. It's actually doing fine. So I want to test the generalization of my model on unseen data that I kept separate. So that is why validation and testing, if you are having only two divisions, they could be interchangeably used. In which case, you say, okay, I'm testing my model or I'm validating my model. That's okay. However, when you divide into three, then they become totally separate. So I have 75% for training, 15% for validation, and another 15% for testing. That is, it's okay. So during the validation, I train, I validate, I train, I validate. Finally, I'm going to check it later with another third one. It's like doing thorough or repeated testing to be sure everything is fine. But if my data is not enough, I divide it to only two. I only have testing alone. So you don't have the two separately. So I hope that clarifies the question on difference between testing and validation. They are both used to check, as the name validate or test, is to check if what you have trained, the model you have produced, if it is correct. You want to validate it. Is it good model? You want to check it. Now, so is validation and testing said the same thing? Yeah, I said it could be synonymous, but if you have fed them separately, it is still the same. They are carrying out the same purpose, but in different stage. One is used immediately after the training, while the other one is going to be kept after you have done, hyperparameter tuning, I'm not going to do any other thing on my model. I've finalized my model. Now we bring the final testing to check if we are still able to get the same thing we were getting during validation. And sometimes we don't have enough data. We only have one training set and one testing set. It is still okay. When is Kalman filter and fuzzy logic used in conjunction with other algorithms for prediction? Thank you very much. So hopefully this is an area we'll have the opportunity to touch one of these days. You see, Kalman filter and fuzzy logic that sometimes we might use as an hybrid model, whereby we have a system, we use this Kalman filter to filter the system. Or I have used fuzzy logic a lot, fuzzy logic type 1, fuzzy logic type 2. So I use it a lot to see if the data is very noisy. When you have noisy data, uncertainty in your data, we can use fuzzy logic to first of all train the system. I mean, to first of all clean the system, clean the data so that you have data that is now reliable before you now push it to the algorithm. So in an hybrid system, we do use it as a kind of pre-processing or in an hybrid setting to clean our data. Then later we use it for the predictive solution. And sometimes also we have fuzzy logic system that by itself is also a classification problem. It's also a regression solution. Yeah. We also have algorithms that are fuzzy logic type 1 and fuzzy logic type 2 for modeling. That without attaching them to other algorithms, we can use them for prediction separately as an individual standalone machine learning algorithm. So we'll have opportunity in future to talk more in detail about fuzzy logic. Fuzzy logic is a big concept. It takes logic totally away from what we know. We all know fuzzy logic are there 0 or 1. Fuzzy logic is saying no. Just sometimes it doesn't make sense to say 0 or 1. Things are in between, neither 0 nor 1. But there are a lot of things that are in between, and there's a majority of things falls on in between 0 and 1. They are neither 0 nor 1, but in between the two. So fuzzy logic try to resolve this particular area that human beings, we have missed a lot on them. So for sure, we are going to try to see how we're going to slate fuzzy logic as one of our discussion in one of these days. So especially for those people who might be interested in those areas, because it's going to take us a little bit of mathematics and a kind of higher level machine learning. Maybe towards the end of the questions, what is the main difference between machine learning and other statistical methods? I think I briefly explained this one. I said statistical methods, they are good. However, they are now getting limited capability because of the nature of data set we are having. If data set is not clean, statistical method will do it the way it is. Now we have in machine learning, we can incorporate fuzzy logic, genetic algorithm, and all that pre-processing stuff to make our data cleaner, and we can use machine learning to get better results. And also, even without cleaning issue, machine learning has the capability to solve problem better than the statistical methods. And also, I've mentioned the issue of data in motion. When your data is in motion, especially big data, statistical method might not be usable because you need to freeze the data before you can use statistical method on them. But machine learning has the capability to work on data set in motion and those ones that are not in motion and with better result outcome. So I hope I differentiate that. So there are a lot of other differences anyway. Okay, thank you, Mr. Chris has provided link to YouTube channel. So let us explore some of them, what we have discussed. Can you use Weka for data cleaning, especially for cybersecurity data? Yeah, so depending on the kind of cleaning you want to do, we can do a lot of cleaning, pre-processing system in Weka, and our model train in Weka deploy in production system. Yeah, so this is an area where actually the support of the kind of developer might be needed. So if you have to deploy into real life usage. So for now, you train your model. For now, you train your model and then you use it in the Weka environment. So deploying it will be another thing entirely, which if the client really needs, then in that case, that might involve higher level of system that will involve some coding in the Weka environment and some other things that can make it deployable, because that is kind of deploying to production for a client. Usually open source might be limited in that particular respect, but it's not impossible. Can Wika help us to do statistical difference between the result, or you have to use statistical tool? Yeah. So Wika will give you the visualization, the plotting, the difference between the output and the input. But for me, I like to take it out. Sometimes I do it in Excel myself. It's up to you. You can export the result from Wika to the Excel and play with it as you want. Wika also has a way of doing that for you to do the visualization and other stuff. So, alhamdulillah, wa anta wa jazakallah khairan. So I think those are the questions we have on the chat. If anybody has any further question, so we can raise our hand for like a few more questions before we call it a day. Thank you very much all for listening and for the attendance. So any further clarification or comments from the